Welcome to the on-board video training program of Carco. This video will illustrate the properties, uses and hazards posed by the use of nitrogen on board chemical tankers. One of the main constituents of the atmosphere surrounding us is nitrogen gas, which accounts for about 71% of the same. We will use a green color to depict nitrogen gas, which in reality is a colorless and odorless gas. Let us first understand the main physical and chemical properties of nitrogen gas. Nitrogen is a non-flammable gas and does not support combustion. Hence, a tank filled with nitrogen, which replaces oxygen to below 8% volume, is protected from any fire hazard. Nitrogen being an inert gas, a tank filled with the same will not allow most chemical cargoes in the tank to react with the external atmosphere and keep the cargo tanks isolated. The dew point of nitrogen is minus 40 degrees Celsius. Hence, it is termed as a drying gas. A tank filled with nitrogen will drive away all the moisture vapor in the tank, which may adversely affect a cargo. The one drawback of nitrogen is that, although not toxic, it does not support life. Any tank which has been purged with nitrogen and the oxygen content reduced to below 21% may lead to a casualty if an uncontrolled entry is made. The nitrogen supplied on board may be from various sources, such as from a shore facility, which can be at very high flow rates with pressures up to 10 bars, from a nitrogen generator provided on board at controllable flow rates, from bottled nitrogen carried on board. Nitrogen supplied on board may have a purity ranging from 95 to 99.99%, subject to the source and the intended use of the same. Due to the sensitive nature of chemical cargoes, which will be in contact with this nitrogen, any source should provide this gas free of contaminants, such as water vapor, sulfur dioxide, etc. Nitrogen finds several practical applications on board chemical tankers, which are inerting of cargo tanks, padding of the cargo tanks, drying of cargo tanks, and clearing cargo lines where air cannot be used. The nitrogen, when used to reduce oxygen content inside the tank for purpose of controlling the flammable atmosphere, would be termed as inerting of the tank. The nitrogen, when used to reduce the dew point of the atmosphere of the cargo tank, would be termed as a drying operation. The nitrogen, when used in the ullage space after completion of cargo, for purpose of isolating the cargo from any contact with the atmosphere, would be called padding. The use of nitrogen poses some operational hazards. A standard cargo tank on board a chemical tanker is designed to withstand a positive pressure in the region of approximately 3,500 mm water gauge of vapor pressure or 34 kPa, with some tanks being specially strengthened for which the Ship-Specific Chemical Operation Manual should be referred to. To prevent the tanks from being subjected to this design pressure, Tanks are provided with pressure vacuum relief valves, which are generally set at a pressure setting of 2100 mm of water gauge, or 20 kPa, and vacuum settings of 350 mm water gauge. Secondary means of pressure and vacuum monitoring is provided as per regulations and, in many cases, includes the use of pressure sensors inside the cargo tank or on the vent line. If the cargo tanks are subjected to pressure exceeding the design pressure of the tank, it would result in the tank structure being damaged, which, in turn, could lead to more disastrous consequences of explosions, fire, and subsequent loss to life, ship, cargo, or environment. An oxygen-deficient atmosphere may develop in the vicinity of open hatches in some weather conditions, when nitrogen is vented through the tank hatch or tank cleaning hatch, and there is not much wind turbulence in the vicinity. Exposure of personnel to liquids or gas if the operation is not carried out in a controlled manner. In a loaded tank, padding carried out after completion of loading of low pour-point cargoes may lead to blockage of pipe vents and valves. Overpressurization of tanks can also occur when line clearing activity by compressed gas or pigging is performed by the terminal, or when loading from rail cars. We will now understand in detail the operations posing these hazards. When a cargo tank is required to be inerted, or purged, or padded using nitrogen being supplied by a shore facility, the following factors need to be understood. The shore nitrogen may be supplied using a pipeline of various diameters and at various pressures. It is very important to understand the requirement of the vessel before any nitrogen padding or purging is carried out. A standard table is provided which gives the volume of gas flowing through pipes of various sizes and at various pressures. Also available is a table which gives the time required to carry out an atmospheric exchange of a standard cargo tank of 1250 cubic meters, considering 4 volumetric exchanges. Let us look at a cargo tank filled up to 95% of its capacity of 1000 cubic meters. It receives nitrogen from shore through 150 mm diameter line at a pressure of 2.1 bar. As per the table, the flow rate is 457 cubic meter minute, or 27,400 cubic meters per hour. The pressure vacuum valves are designed to vent at a rate of, say, 880 cubic meters per hour, or 14.7 cubic meters per minute. As seen, the inflow rate is about 30 times that of the outflow rate. The tank pressure will rise very, very quickly, and if corrective action is not taken immediately, it will surely result in damage to the cargo tank structure. When required to use the vapor emission control system of the vessel for purging of the cargo tanks, the VECS manual should be referred to determine the maximum purging rate for the cargo tanks. In case this rate is exceeded, the excessive pressure will be released through the PV valves, which is also not allowed. If the nitrogen is vented through the open oil tank hatch or a tank cleaning hatch, and there is not much turbulence on the deck level due to the winds, there is a possibility of a drop in oxygen level in close vicinity of these openings. If the purging or padding operation causes a spill of the cargo on deck, or expulsion of gases at the deck level, some may expose the ship personnel to a possible health or pollution hazard. Line clearing is carried out on completion of loading to clear the contents of the pipeline into the tank. This may be done using compressed nitrogen or a pig driven by nitrogen gas. An uncontrolled operation of introducing high-pressure gas, which will expand once it enters the tank, can lead to the pressure inside the tank increasing beyond the permissible limits. As this operation needs to be carried out using high-pressure gas to effectively clear the contents, there is a strong possibility of this pressure increase in the tank. The precautions described are for a chemical tanker, which loads into a clean and gas-free tank, and not an oil tanker, whose tank may contain flammable and toxic gases, and will require additional precautions. Before any sure nitrogen is received on board, the entire procedure is required to be discussed with the shore representative and the details recorded. The following Company Pacific documents are to be completed. 1. Ship Shore Safety Checklist, Item Number 70. 2. Ship Shore Agreement, M05, Appendix 9. 3. Cargo Operation Plan, M09, Appendix 9. The number of tanks requiring purging or padding, the quantity of the gas required, the maximum flow rate by terminal, the nitrogen supply arrangement of shore, including the pipe diameter and the pressure, should form part of the discussion with the shore personnel. A toolbox meeting should be carried out separately to ensure all the ship's key personnel are well aware of the agreed procedure to follow for the intended operation of the use of nitrogen. If tanks are to be inerted before loading, following checks need to be carried out. To inspect and check conditions of PV valves, to ensure that the piping system is lined up correctly and necessary valve positions checked. In case of entry into cargo tank for inspection, company tank entry procedure must be complied with, as well as terminal permission which is required. Additionally, to confirm that the nitrogen purging line is isolated by blanking or other permanent mean. Isolation by closing valves is not adequate to meet the requirement. The loading master must be advised of such activity. To confirm no foreign material or personnel are in cargo tank by head count. A lockout-tagout system may be used to identify inerted tanks and/or tanks inspected and ready for inerting. To keep close contact with shore during such operations. To hang up warning placards at oil-tight hatch, manifold valve, and PV valve stack. To draw the attention of N2 purging operation to all ship's crew by public address system.
Keep clear of the entrances and the PV stack. Attention all ship staff. 5 starboard cargo tank will be purged with nitrogen. Keep clear of the entrances and the PV stack.
To confirm pressure monitoring system is working. 2 SCBAs and 1 oxygen resuscitator to be kept standby at the catwalk level in readiness of possible anoxic environment developing due to inadvertent nitrogen flow on deck. Crew to be ready at manifold and at valve stand to divert the nitrogen to the next designated empty tank and/or stop supply of nitrogen to the concerned tank as necessary. The personal analyzer is to be worn by the deck crew involved in the operations, and such equipment must be tested before use. In any case, the atmosphere on deck must be checked continuously during the operation. If venting only through the PV system, then the rate should be as per the designed capacity of the PV, giving due allowance to the liquid loading rate, with a factor of 1.25 for vapor growth and vapor density. If using the VECS system of the vessel for purging, the only way is to control the flow rate of nitrogen from shore, else the PV may open to release additional pressure which will be in contravention of regulations. One of the most preferred ways of controlling the flow is by using a small diameter pipe at the manifold, whereby an increase in the pressure will be safely handled by the pressure vacuum valve provided on the tank. The possibility of using a reducer fitted with a gas control valve to be checked. A pressure gauge should be fitted to monitor the pressure inside the tank. If tanks need to be padded on completion of loading, a preferred way would be to purge the tank before loading, and then vent the nitrogen during loading, with finally leaving the tank with a positive pressure of nitrogen. This will prevent incidents of splashing or cases of gas traps to cause spillages on deck. However, if the tanks need to be padded only after completion of loading, the following precautions need to be observed. The nitrogen is bubbled through the cargo to the vapor space on top. The venting should take place through the oil tank hatch if there is no restriction to the same due to the nature of the cargo, and no restrictions from the terminal to the same. Keep the oil tank hatch open by about an inch to permit easy venting. Venting continues till the required oxygen content in the tank is achieved. It is important that the flow of nitrogen in the tank is controlled gradually and avoid any abrupt changes in flow which will cause a large volume of air bubbles forming and possibly causing splash of cargo from the tank hatch. The person monitoring the oxygen content should stand at an angle of 90 degrees to the lee side of the wind direction. He should use a portable oxygen meter to monitor the tank atmosphere, and also wear a personal multi-gas meter to monitor the atmosphere around him for any toxic gas or depletion of oxygen. If venting at deck level is not permitted, the flow rate has to be maximum 80% of the PV valve setting, and the oxygen content is to be monitored from a sample cock in the vent line. Other precautions are the same as for inerting the cargo tank. On completion of the cargo tanks being inerted or padded, confirm complete gas tightness of all openings to the concerned tank. Record the tank pressure and oxygen contents of individual tanks. Display the signs, placards, labels, at the tank hatch after completion of loading operations. Such placards, labels or signs should be displayed in English. Confirm PV valve set in correct position. A tank entry procedure is required for all tanks previously inerted, as well as their adjacent spaces, compartments. There are some additional operations which could lead to an increase in the pressure inside the tank. There could be sudden increase in the vapor pressure inside the tank due to line clearing operations, and also while loading from the rail cars due to their operational procedures. Pipelines are cleared using nitrogen gas or with the use of a pig. Due precautions are specified in the company's QSMS manuals to be observed. Adequate crew to be available at the time of inerting purging operations, to handle the changeover of tanks, and to effectively conduct and monitor the situation. The purging or padding operation should be a well-controlled operation at a slow rate to avoid any uncontrolled situation from developing. Some other sources of nitrogen on board are a nitrogen generator fitted on board, which will generally be of a medium capacity and may not present a hazard of overpressurization of the cargo tanks. This nitrogen is supplied through the ship's dedicated fixed cargo piping, leading to a reservoir and then through a pressure relief setting system to the cargo tanks. Also provided on board may be high-purity nitrogen contained in bottles carried at a pressure of 200 bars. This is a limited supply and generally used to top up the cargo tanks during the voyage if required. Some cargoes require a padding of nitrogen throughout the passage and at the same time need a minimum percentage of oxygen, as there may be an added inhibitor in the cargo, which is oxygen dependent. Nitrogen gas is very useful on board chemical tankers, but it is essential for the ship's staff to understand the operational hazards, with the principal one being of damage to the ship structure due to excessive pressure. Keep your life, ship, and environment safe.